Hello dear students, welcome to the lecture on logic gates. So far we have discussed analog electronics which include diodes, Zener diodes, transistors, etc. So from now on what we are discussing is digital electronic technology. So logic gates are the basic building blocks of the digital systems. Okay, so logic gates are the basic building blocks of most of the digital electronic systems. So the present day computers, calculators, etc. are based on digital electronic technology. Okay. Digital systems are designed to operate with binary numbers. Binary refers to 2. So only two digits are there in the binary number system, that is 0 and so these are called bits. 0 and 1 are called bits. Digital systems are designed to operate with this binary number. Logic gates are the basic building blocks of the digital electronic system. Logic gates are electronic devices which make logic decisions. It can have one or more inputs and an output. The different combination of the inputs and the corresponding output is listed in the truth table. So a truth table lists all the possible input combinations of a logic circuit and corresponding output. So ഇതിനാണ് പറയുന്നത് ഒരു ട്രൂത്ത് ടേബിൾ എന്ന് പറയുന്നത്. The input and output can have either 0 and 1. ഇൻപുട്ടും ഔട്ട്പുട്ടിനും രണ്ട് പോസിബിലിറ്റി ഉള്ളത്, ഒന്നുകിൽ 0 അല്ലെങ്കിൽ 1. This 0 corresponds to low voltage and 1 corresponds to high voltage. Or you can say that it is off state and this one is on state. Now the functions of the logic gates is based on the Boolean algebra. So logic gates are working based on Boolean algebra. There are three fundamental gates now. OR, and NOT. These are the three fundamental logic gates. Making use of these three gates, we can construct all other gates. So that is, there are NOR gate, NAND gate, and XOR gate, exclusive OR gate. These are other gates. We can use these gates to construct all these gates. Now, using only this NOR gate or only using NAND gate, we can construct all other gates. That's why these two gates are called universal gates. A NOR gate is the combination of OR gate and NOT gate. Similarly, NAND gate is the combination of AND gate and NOT gate. But using only NOR gate, we can construct OR gate. Using only NOR gate, we can construct AND gate also. Similarly, all other gates can be constructed using NOR gate. So that's why NOR gate is called universal gates. Similarly, NAND gate also a universal gate. Okay. Digital systems can employ either positive logic or negative logic. Positive logic means there are two bits, 0 and 1. 0 represents low voltage and 1 represents high voltage. This is called a positive logic. Okay. If 0 represent high voltage and 1 represent low voltage, then this is termed as negative logic. ഓരോ ഡിജിറ്റൽ സിസ്റ്റത്തിലും ഒന്നുകിൽ പോസിറ്റീവ് ലോജിക് ഉപയോഗിക്കാം അല്ലെങ്കിൽ നെഗറ്റീവ് ലോജിക് ഉപയോഗിക്കാം. പോസിറ്റീവ് ലോജിക് എന്ന് പറഞ്ഞാൽ നമ്മൾ ദിസ് ഈസ് ദ കൺവെൻഷണൽ വൺ. 0 എന്ന് പറഞ്ഞാൽ ലോ വോൾട്ടേജും 1 എന്ന് പറഞ്ഞാൽ ഹൈ വോൾട്ടേജ്. തിരിച്ചാണ് ഉപയോഗിക്കുന്നതെങ്കിൽ സോ ദാറ്റ് ഈസ് കോൾഡ് നെഗറ്റീവ് ലോജിക്. Okay. Let us now discuss the basic gates. First one is OR gate. Okay. An OR gate can have two or more inputs and an output. Okay. The symbolic representation of an OR gate is like this. So input A and B, output is this Y. So the Boolean expression of the OR gate, a two input OR gate is given by Y equal to A or B. Okay, so this is read as A or B. OR gate has output high if any one of the input is high. Okay, so that is the specialty of OR gate. The output is high if any one of the input is high. Now let us see how a two input OR gate is constructed using diodes. So we can take two diodes, diode D1 and D2. The N region, N side of the two diodes are joined together and it's connected to the load resistance. Okay, and the P sides are the input A and B respectively, and here the N side which is connected to the load resistor. So this is the output Y. So the truth table of an OR gate is like this. A B, output Y, 0 0 0 1 1 0 1 1. So the output is high if any one of the input is high. So both are 0, so therefore it is 0. So here it is 1. The output is 1 for this also. The output is 1 for this also. This is the truth table of OR gate. Now, okay. Now let us consider we give input voltage to the A and B. So we can measure the corresponding output voltage from here. So A is connected to 0 voltage. A is connected to 0 voltage. B is connected to 0 voltage. So the both diode D1 and D2 are not conducting. So D1 not conducting. Therefore output is 0. Y equal to 0 in this case. Okay. Now next is A is 0, B is 1. B is 1, that means 5 voltage. If we apply 5 voltage here, then this diode D2 conducts. D2 conduct. Therefore, this 5 voltage will reach here. So output will be 5. Output is 5, that is 1. Okay. Now next case is A is 5. That means A is 1 and B is 0. Therefore, D1 diode D1 conducts. Therefore, that output, that 5 voltage reaches here in the output. So Y is equal to 1. If both A and B are 1, okay, so both the D1 and D2 conducts. So this is, since these are parallel, so we get 5 voltage in the output. So therefore Y is equal to 1. So this is the working of OR gate. Next, let us see AND gate. An AND gate can have two or more inputs and an output. Okay. The output is high only when if all the inputs are high. Okay. A two input AND gate. So the symbol of a two input AND gate is like this. Input A, B, and this is Y, output Y. So the Boolean expression is output y is equal to a and b. Okay, a dot b or a and b, or we can write simply ab. So y is equal to ab or a and b. The construction of an AND gate using diodes. A two input AND gate using diodes. So we have to take two diodes, diode D1 and D2, diode D1 and D2. P sides are joined together and it is connected to the load resistance. From the load resistance, a battery is connected. The negative terminal of the battery is grounded. And this point is the output Y. Okay, so these are two inputs A and B. So n regions of n side of the two diodes are the input side. Okay, so this is the circuit diagram for a AND gate. Now let us see what is the truth table. The truth table of AND gate is and for an AND gate the output is high only when all the inputs are high. So this is here output is 0, this 0 1, then output is 0 1 0, also have the output 0. If both A and B are 1, then output is 1. Let us see how to accomplish this truth table using this circuit. Okay, so when A equal to 0 and B equal to 0, that means this A and B are grounded. Okay, that means 0 voltage. So at that time, here already we have 5 voltage here. So this 5 voltage and here 0 voltage. So the diode T1 and D2 are forward biased. Diode D1 and D2 are forward biased. Therefore, the current flows through this load resistance. Okay. So this 5 voltage is dropped across this load resistance. So the output in the terminal Y is equal to 0. So here the diode D1 and D2 conduct. So the voltage is dropped across, this 5 voltage is dropped across the load resistance. So here plus 5 and minus 5 is here. So total at the point Y, the output is 0. So Y is equal to 0. Okay. Next is when A equal to 0, B is equal to 1, that is 5 voltage. Okay. When B is 5 voltage, then what happens? Since A equal to 0, this diode D1 conduct, because here 5 voltage is there, here 0 voltage. So this point 5 voltage is there, at this point 0 voltage. So diode D1 conduct. When diode D1 conduct, this 5 voltage is dropped across the load resistance. Okay. So current flows through the load resistance. We know that V equal to I into R. So when current flows through this thing, the entire voltage will be dropped across this thing. So 5 voltage minus 5. So at Y it will be again 0. Okay. So here D1 conduct. D1 conducts. D2 does not conduct. Then next is A is 5 voltage and B is 0 voltage. So that means 1 0. So here the diode D1 will not conduct because here 5 voltage. So 5 voltage, 5 voltage, the diode is not forward bias. But here the second diode is forward bias because to B it is 0 voltage. So the current flows through this diode D2 through the load resistor. Okay, so the 5 voltage is dropped across the load resistance. So the output will be 0. So here D2 conducts, okay, but not D1. So therefore the voltage will be, the voltage at Y is equal to 0 voltage. Next is, the last one is, both input are given 5 voltage. Okay, so that means we have given the plus 5 voltage to A and B, then there is no potential difference across the diode, so that both the diode will not conduct, D1 and D2 will not conduct. Therefore the output is, so it will not conduct, so there is no voltage drop across, there is no current flows through the load resistance, therefore there is no voltage drop across the load resistance, so there will be all the 5 voltage at the input Y, okay, because no current flows through this load resistance. So this is the last input combination, so 1 1, the output is 1, 5 voltage means 1. Okay, this is how an AND gate works. Okay, now we wanted to discuss how a NOT gate works. Okay, so first let us see what is a NOT gate. A NOT gate has one input and one output. So the NOT gate inverts the state from 0 to 1 or 1 to 0. It is also called an inverter. We can see what is the symbol first, symbol of NOT gate. So this is the symbol of a NOT gate. A, this output Y, which is equal to A bar. A bar means A complement. Y equal to A naught, we can say that. So if 0 voltage is given in the input A, then we will get 1 voltage. That means high voltage in the output. If high voltage is applied in the input, then the output will give 0 volt. Okay, so that is the purpose of a NOT gate. So we can draw the truth table. So truth table of, so this is first A, if 0 voltage is applied, then the output will be 1. If high voltage 5 voltage is applied, that means 1 is given to the, 1 state is in the input, then the output will be 0 state. Boolean expression is, output Y is A naught. Okay, a complement, we can say that. Next is circuit. A NOT gate using transistor. Okay, so we are using a transistor to construct a NOT gate. So a transistor in common emitter configuration. So a transistor has emitter, base and collector. We give input, this is base, collector, emitter. Input is the base is the input, and the collector is connected to the high voltage plus 5 volt. Okay, so we can say this is VCC, PCC through a resistance RC. Okay, and the output is taken from the collector. So this is the output Y, and the emitter is grounded. This is a NOT gate. Next, let us see how the NOT gate works. If the input A is equal to 0 volt, A, if A 0 voltage is applied, that means there is no voltage. So the input voltage is 0, therefore input current also 0. Okay, so base emitter junction is not forward biased. Therefore we can say that the transistor is in off state. When input current is 0, the transistor is off state. So no current flows from the collector to emitter. Okay, so there is no current flow through the resistor, so that 5 voltage will be there in the Y. So the Y, the voltage, the potential at Y is equal to 5 volt. If 5 voltage is applied in the input, what happens? The transistor is on state. Transistor, okay, transistor is in on state. When transistor is on state, current flows from the collector to emitter through the transistor. Okay, so this current is flowing through, actually through the resistance RC. Therefore there is a voltage drop across RC. So this, there is, even though there is plus VCC 5 volt, that voltage will be dropped across RC. So here 5 plus 5 and across RC minus 5. So there will be the potential at Y is equal to 0 volt. Okay, so when we give input a 0 in the input, we'll get a high voltage in the output. If we give high voltage in the input, there will be 0 volt in the output. So this, that is why this is called an inverter. So this is the working of a NOT gate. So we have finished the OR gate, AND gate and NOT gate. So we will discuss the NOR, NAND and XOR gate in the next class. Okay, thank you.